Hello, Algebra 1. We have been talking about how to solve linear systems for the past couple of days, but we've been drawing graphs to do that. Chapter 7.2 teaches you an alternative method that's faster and tends to give answers that are more reliably accurate. It's called the substitution method. Let me use an example that's different than the one the textbook starts with. I'm going to start with question 8 off of page 408. And here's what you were given. This is a linear system. In other words, two different equations, two different linear equations more specifically. And if I wanted to figure out where these two linear equations, in other words, these two lines, cross, one thing I could do is look at this 5y equals 15. Well, wait a minute. If 5y is 15, well, if I divide both sides by 5, that means y is 3. And I can make use of that fact. If y is 3, I could plug that back into the first equation. Now I've got 3x minus 3 is equal to 0. Well, if that's true, then I move this 3 here over to the other side, and I've got 3x is equal to 3. That means x is 1. This is suggesting that the point 1, 3, in other words, where x is 1 and y is 3, that should work for both of these equations. Let's just double check that. Let's try plugging it back in. So I'm going to give placeholder parentheses here instead of writing x and y. And in place of x, I'm going to write 1, and in place of y, I'm going to write 3. Well, 3 times 1 is 3. 3 minus 3, that is 0. 5 times 3, well, that is 15. And sure enough, the textbook tells you the same thing that we figured out here. 1, 3 is the solution to this linear system. And you could have graphed this. You would have come up with the same answer. But this was faster. It's not always that easy, though. And the first example that the textbook gives is this one. Here's the linear system that you have, the two different linear equations. And similarly, they're saying what you ought to do is pick one that you're going to work with first. So they've picked equation 1, and they've changed equation 1. So instead of calling it negative x plus y equals 1, they've moved the x to the other side. So it became a y equals equation. Y equals, well, again, that x moved to the other side became positive x, so it's x plus 1. Okay, now that y is x plus 1, well, now that you know what y is, instead of calling it y, from now on, if you want to, you can call it x plus 1. They mean the same thing. That's what an equal sign means. That means if any place that I was going to say y, I can say x plus 1. So in the second equation, that's what I can do. Instead of saying 2x plus y is negative 2, that second equation becomes 2x plus x plus 1 equals negative 2. The benefit of doing this is now this row here, this equation here, only has one letter, one variable. And I can put the x's together, the 2x and the x, and get 3x. We got 3x plus 1 equals, that used to be an equal sign, it seems somehow it got blurred out, that's an equal sign, negative 2. And I can just keep going until I finally solved it, and I'm going to get x is negative 1. Okay, well that second step has now told me, and by the way, just to remind you, the first step was to get one equation to solve for either x or y and to plug it into the other. The second step, as explained here, was to figure out what one of the letters is. I now know what one of the letters is, negative 1. Now I can put that back into the first equation that I was working with. I can leave it the way it was, or the textbook suggests put it back into the revised version. Well, the revised version, if you look back in the textbook at equation 1, the revised version is x plus 1. Well, I don't have to call it x anymore. I can call it negative 1. So that means y is negative 1 plus 1. In other words, y is 0. Now I know x and I know y. And that suggests that the two lines cross at negative 1, 0. But you can always check. You plug those back in. Remember, this was the system. Instead of it writing it this way, I can write placeholder parentheses, and where, whoops, didn't mean to do that, where I used to have x I can now write -1, and I can write 0 for y. That's what I've done here. And let's see, negative -1. Well, that's +1. 1 plus 0, that is 1. 2 times -1, that's -2. -2 plus 0, that is -2. And sure enough, the solution is, just like we thought it was, -1, 0. Okay, so I don't know if you realized or noticed as we were going along, but we were working with 4 steps. This box, this green box with these 4 steps is straight out of your textbook. So look at it and make sure you understand it. Basically, step 1 is this stage here, where I'm going to solve or rewrite one of the equations. It says for one of its variables. In other words, I'm going to turn one of these equations into an x equals or y equals equation so that it's easier to work with. Like here, I turned one into y equals. Well, notice it says one of the equations, one of its variables. I don't have to start with the first equation and first variable. That's a key point that a lot of students miss. Make sure you get this. For example, for this one on the left, I used the first equation but second variable. For the one on the right, I didn't even use the first equation. I used the second equation. But in both cases, I turned it into a letter equals something statement. In this case, y equals x plus 1. Over here, I remember that this one became y equals 3. You don't have to solve for y. You could have done x, but that's what I picked in these cases. The second step then, once you know, for example, here I know what y is, I'm going to call it x plus 1 for now on. Put x plus 1 into the other equation. So here, for example, I turned this one into here. So now, instead of calling it y, I'm going to call it x plus 1. Now, x plus 1 goes into the other equation. It goes in here. So it became 2x plus x plus 1. Look back through the example if you need to. It's in the textbook. Step 3. I'm going to get a result. I ended up deciding over here what x became. Once I know what x is, substitute the value you get out of step 2 back into the other equation. So I knew what x was. I plugged it in place of x here. Or I think I actually used this version. I plugged it in place of x here, and I was able to figure out what y is. Once you know what both x and y are, double check, make sure you have it right. Make sure you haven't made a simple arithmetic mistake. All this work can really be wasted if you make a simple arithmetic mistake. So just check your solution at the end. All right, let's practice this skill, this first skill, step 1 here, of choosing one of the equations and solving it for one of its variables. Here are 3 different choices. I'll walk you through number 7, then you're going to do number 8 and number 9. For number 7, I would pick the y, the positive y here. I'd want to get that by itself. I've got 4 choices. I could get x by itself here, y by itself here, x here, or y there. I've picked this y because it's positive and it doesn't have any number in front of it to mess with. I'm going to move the 2x over. Y in this case becomes -2x. Alright, based on that, go ahead and do number 8. Choose for yourself which one you want to work with. Hit the pause button when you come back. I'll show you what I chose. Okay, I'm going to assume that you did that. I chose to get b by itself up here and to move the 2a. So b became positive 2a plus 7. How about for number 9? Again, hit the pause button when you come back. I'll show you what I've chosen to do for number 9. Okay, again, I'm going to assume that you did that. I chose to move this -3n, so to solve for m. So once I moved the -3n over, I had 2m is equal to positive 3n plus 6. But I didn't want 2m, I wanted just m. I got to divide by 2. I'm going to keep saying this so many times this year. Divide everything, each term, each piece, by that 2. And you're going to end up with m equals 3 over 2n plus 3. All right, well now that's the end of step 1. Step 2 is to plug it back into the other equation. So for this one, for example, for this one, for example, I plug the negative 2x in place of the y in the other equation. In this case, I plug 2a plus 7 in place of b in the other equation. And in the last one here, I plug that in place of m. So it's going to be 2 times all this stuff in parentheses plus 5n equals 14. So clearly number 9 is going to be the hardest one to work with. The textbook gives another example. I'll walk you more quickly through example 2 before finishing up the lesson, just to make sure everybody's clear on this. Remember, there are 4 steps. The first step, solve for one of the letters, one of the variables. I've got 4 to choose from, 1, 2, 3, and 4. This time the textbook decided that was the easiest one to work for, so it moved the 4y over. That's how it got this statement at the end of step 1. Now for step 2, it put this 4y minus 1 in place of x in the other equation. In other words, instead of x, it said this stuff in this other equation. So 2 times not x, but all this stuff plus 2y becomes equal to 3. All right, we're at this stage now. 2 times that stuff, well, that's 8y minus 2. 8y minus 2 plus 2y. 8y minus 2 plus 2y, well, I can put the 8y and the 2y together. I'm going to end up with 10y minus 2 is 3. Move the 2 over, I'm going to have 10y equals 5. And I'm going to end up being able to say that y is equal to 5 over 10, or in other words, 1/2. Now I know what y is. I put y back into the original equation, but its revised version. That's the textbook's way of doing it. They say go for the revised version of equation 2. So put a half instead of saying y. Oops. So that was my revised equation. Instead of saying y, though, I said a half. 4 times a half is 2. 2 minus 1 is 1. Now I know x is a half. I'm sorry, y is a half. X is 1. So double check and make sure 1 comma 1/2 actually solves. And you'll find if you do that, if you plug it into both equations, that it does work for both. So 1 comma 1/2 is the right answer for that example. One last point. We did talk a lot about graphing, and it's not wasted effort. You can always double check and make sure your answer makes sense by drawing a graph if you want to. So 1 comma 1/2 really will work if you graph both of those equations that we just worked on for example 2. Okay, that's it. In addition to what you've already done, in addition to this video, all you have to do now is 2 problems on page 408. Bring those into class. If you can solve those, I'll be convinced. And don't just show me the answers, show me the work. But I'll be convinced if you do that, that you've watched and understood the video lesson. And we'll go over these in class next time we meet. Also, if you have any questions, bring those. See ya.